Imagine a world where developer automation tools aren't merely functional, they're actually a joy to use. Today, we'll unlock 3 concepts that can take a user experience from average to amazing. We'll cover designing for interaction modes, where we balance a range of ways users can interact with a product. Then we'll introduce the concept of producing versus consuming to help users get the most out of automation, whether they're building or benefiting from it. And finally, designing non-linear workflows, because not every process follows a straight path. Together, these are essential to crafting intuitive developer experiences. I'm Jed, and I'm a product designer at Octopus Deploy. This talk is aimed at designers, but if that's not you, stick around. Hopefully, this gives you some insights into how we, as product designers, think about building experiences that meet users where they are, while making day-to-day workflows smoother. So let's dive in, starting with interaction modes. Many products you interact with are focused on a single mode. Think visual interfaces in a software product. But some physical and digital products include different modalities, which is a fancy way of saying a different way to interact with a product. In a multimodal tool, the goal is to seamlessly integrate and optimize the user experience across various modes of interaction. Think about driving your car. You might use a voice command to change your tunes. Then you might use a touch screen to adjust the temperature. Then the steering wheel to avoid that pigeon on the road. Cars provide multiple ways for drivers to interact with the system safely, depending on their preference and what's convenient while driving. It's all about what feels safe, intuitive, and appropriate for the task. The same is true for developer tools, although perhaps with slightly less safety consequences. Whether someone prefers the precision of a CLI or the ease of a visual interface, the goal is to make sure both interaction experiences feel seamless and efficient. Octopus Deploy is a multimodal tool. Users have several ways they can interact directly with our product. Through the web portal's user interface, the API, the CLI, configuration as code, and Terraform. If an experienced user prefers to edit their deployment processes in code, we should strive to offer that. If a new user expects a UI to learn the product, then it's in our best interests to offer that. If an automated batch process is more efficiently handled through our API, great, do it that way. Ultimately, we aim to deliver an experience that caters to our users' preferences. A great example of this is our config as code offering. Most competitors lock the UI when config as code is being used. But we've found that our customers typically still want to use the UI in this scenario. The main benefit of config as code isn't the code as the interaction tool. Code is how they want to store their deployment process. Maintaining the editable UI as well as code was the real differentiating aspect of this feature. So what kinds of benefits contribute to a more versatile, inclusive, and user-friendly experience across interaction modes? Well, for one, there's increased productivity. Multimodal interfaces can enhance productivity by allowing users to choose the most efficient and convenient mode for a specific task. A simple edit might be fastest with a code change, while configuring a deployment process from scratch might be more quickly handled through the UI. Reduction of cognitive load. Offering users multiple ways to interact can reduce cognitive load by allowing them to choose the modality that feels most natural for a particular task. This can lead to a more user-friendly and stress-free experience. Improved user engagement. Providing users with different ways to interact can lead to increasing engagement. For example, new users with less proficiency can make more progress if their interaction mode supports their learning of the tool. Personalization and context awareness. Multimodal UX design often leverages context awareness, enabling systems to understand the user's preference, location, and environment. This information can be used to tailor the user experience, providing personalized and contextually relevant content and interactions. The key takeaway here is that providing multiple interaction modes creates a more seamless, intuitive, and efficient experience, allowing users to choose the method that best suits their context. This flexibility enhances usability, minimizes friction, and makes the product ultimately more responsive to individual needs. This results in a smoother and more empowering user experience. Moving on to the next section. Broadly speaking, users of automation tools have two distinct and jointly valuable jobs to be done. There's producing the automation and there's consuming it. They're linked. You can't have one without the other. But they aren't always different people doing this. They're different roles or hats people wear. Imagine a home being built. The architect designs and plans everything, carefully considering structure, durability, and long-term use. The homeowner, on the other hand, simply wants to move in and enjoy their new space. The architect in this story is the producer, building the foundation, while the homeowner is the consumer, benefiting from all that planning and design. Developer automation tools follow the same relationship. Producers create reliable, scalable systems, while consumers focus on getting their work done efficiently within that framework. Here's a real-world example, templating CI/CD pipelines. The producers in this example work in platform teams. They're tasked with empowering their application teams to deploy their software quickly and efficiently. Their job to be done is to build and maintain a CI/CD template. They're responsible for most of the configuration, but allow consumers flexibility to manage the unique needs of their applications. The consumers in this example work in application teams. They want their software deployed with a minimum of fuss. Their job to be done is integrating their code base with the CI/CD pipeline template to automate builds, tests, and deployments. They self-serve their task by using the template, and they're off to the races. Both groups are interacting with this same templating feature, but with different jobs to be done. Understanding the distinction between producer and consumer matters because it changes how we design for them. In a tool like Octopus, there can be clear distinctions in the roles between producer and consumer. It's often a different person at a different time, completing a different task in a different part of the product. The producer is the creator, the designer, and the maintainer of automation tools or processes. They have deep technical expertise in automation technologies. They focus on standardization, reliability, and maintainability. And they work closely with teams to understand requirements and optimize workflows. The consumer benefits from the automation created by the producer. They integrate these automated workflows in their development practices. They have expertise in building software solutions, but not necessarily in automation tooling. They seek efficiency and reliability to focus more on feature development. They rely on automation for testing, building, and deploying code quickly. Producers and consumers collaborate to get their work done. Producers need input from consumers to build automation that fits their needs, while consumers depend on producers for the tools that make their work efficient. The key takeaway here is to recognize that users engage with automation tools differently. Some are producers, some are consumers, and others are both at different times. Automation products should empower them all by offering intuitive tools for building and managing automation. Now onto the final concept. Nonlinear workflows refer to processes that don't follow a strict step-by-step sequence. Instead, tasks or steps can be completed in varying orders, often allowing for parallel work, iterations, or revisiting previous stages. Unlike linear workflows where one task must be completed before moving on to the next, nonlinear workflows embrace a more dynamic approach to productivity. Designing for nonlinear workflows requires flexibility, adaptability, and a deep understanding of how users may navigate and revisit various steps out of order. With Octopus, our users are typically working in a team environment, and a task is often a reaction to an external trigger rather than simply internal motivation. Maybe they're troubleshooting across several tools in their stack, have a break for lunch, complete another task, and then revisit the original task later on. In these situations, they need to regain context and pick up where they left off. Let's run through some considerations for designing nonlinear workflows. Flexibility in task progression. Nonlinear workflows should allow users to move back and forth between steps without friction. Users should be able to jump to any point in the process and resume abandoned tasks. Clear navigation and orientation. Since users won't follow a strict sequence, it's critical to provide visual cues like breadcrumb trails that help users understand where they are in the process and how different tasks connect. State persistence and saving. The tool should automatically save the state at various stages, allowing users to pick up where they left off. This is especially important where tasks may be paused or revisited multiple times. Conditional paths. Users may take different paths based on their needs. Incorporating conditional logic allows for workflows that adapt based on user input or decisions. Contextual guidance. Provide context-sensitive help or guidance depending on where the user is in their workflow. Since users won't always follow a linear path, they may need reminders or instructions relevant to the specific step they're revisiting. Error handling and validation. Ensure that errors are surfaced immediately when they occur, regardless of where in the workflow the user is. Highlighting validation issues at the point of need, rather than waiting for a final review, prevents frustration. Visual cues for incomplete or blocked tasks. Clearly indicate steps that are incomplete or missing necessary inputs, while also allowing users to skip or temporarily bypass those steps without forcing a linear order. Support for parallel processes. In nonlinear workflows, users may work on multiple steps or tasks simultaneously. Ensure the design supports parallel work, enabling users to toggle between tasks or sections without losing progress in either. Here's an example from Octopus. When a trial user creates their first project, they're guided through the setup. This experience addresses all 8 considerations for designing nonlinear workflows. The linear, or happy path, as we sometimes call it, is relatively straightforward, a straight line sequence of progression, and it's a thing of beauty when it works this way. But even in this linear workflow, there are several ways this straight line sequence can introduce non-linear considerations. The user might take the option of selecting config as code. This changes their task sequence. And when this happens, we use conditional logic to react to the user input and update their progress indicator. This proactive measure actually keeps them on a linear path, thus avoiding some of the design considerations of nonlinear workflows. Another possibility is the user might start their project, then for whatever reason navigate away from it. This has now become a nonlinear workflow. They need breadcrumbs to return, and then clear visual cues to understand where they are in the process in order to resume their setup. The system also needs to have persisted that project for it to be resumable in the first place. These nonlinear scenarios need to be identified and then designed thoughtfully. The key takeaway for this concept is that designing for nonlinear workflows is about enabling people to work on their terms at their own pace and with the freedom to choose the order in which they complete tasks. And this ultimately fosters a more natural and intuitive user experience. To sum it up, we covered 3 key concepts. Designing for interaction modes, where we balance a range of ways users can interact with a product. Producing versus consuming, to help users get the most out of automation, whether they're building it or benefiting from it. And finally, handling nonlinear workflows, because not every process follows a straight path. Together, these 3 concepts can transform a developer automation tool from average to amazing.